So now it is time to focus on player movement. The very first thing we need to do here is called authoritative server movement, which is just a very complicated way of saying that the server moves stuff. We're not going to move our player in a way you might be used to. We're actually going to make sure that the server moves our player. And this is a way to prevent people from hacking your game. You're going to see how someone can hack our game very shortly. So let's just get right on into it and start coding authoritative server movement player or server move stuff. Okay, so let's look at our game right now. If I refresh, we are currently this blue little dot. I want it so that if I press on an arrow key or WASD, standard movement keys, that our blue player right here starts moving around on the front end. How do we go about coding that? Well, let's head back on over to our main project code. And I want to go inside of frontend.js. I'm going to scroll to the very bottom. And then I need to add in an event listener. We want to listen for the event of when someone takes their finger and presses down on the keyboard. How do we do that? Well, we can access our window object. The window object is provided to us by any browser we're currently visiting this JavaScript file in. And the window object provides something called add event listener. This is going to be a method in which we can listen for particular events, whether it be key down, click, touch if you're on your phone. The possibilities are endless, but in this case, we want to listen for a key down event. And the second argument is going to be a callback function, just a simple arrow function that provides something called an event object as an argument. So we have this event object. It's arbitrarily named, but it makes sense to call it event since it's providing all the details related to this particular event of pressing down on the keyboard. So if I console log out this event object, save, refresh, and then open up our console, and I start pressing down on our keyboard, I'm going to press WASD. We're going to log out this keyboard event, which provides all these different properties related to the event that just occurred. So you'll see on that very last key down, I pressed the key of D as indicated by this code property. Now we can use this code property to essentially listen for particular keys that are pressed down. We want to make sure that when we press something like W, that we move up. When we press something like A, we move to the left. When we press something like D, we move to the right. And the only way to do that is to listen for the events that are coming through this event object right here, in particular the key code. So let's use a switch case statement to monitor for that particular key we pressed down. I'm going to listen for the event object, and then what was the property called? It was going to be called code. So we want to listen for event.code. And then we can add in a case, which indicates which event code do we want to listen for. Go back to our browser, see that we want to listen for a key. And I'm going to start with W in this case, because I want to use the order of WASD. And to complete our switch case, we add the colon right here, the break statement. And now whenever we press down a key of W, we'll console log out the text, key W was pressed. But it's only going to happen when we actually press the W key, since we have it within the switch case. So let's save and refresh. I'm going to press ASD and then W, and there is our console log. Perfect. You might have noticed real quick, if I click, we have this bug right here. Let's get rid of that. Just go over to event listeners. This is within the default project, and comment everything out right here. We don't need it. We're going to use it later, but it's definitely not needed at the moment. So if we comment all that out, refresh and click, that error's gone, and now we can focus on just pressing W, in which the W key was pressed. So we want to listen for the other keys as well, which are going to control our player movement. And if that's the case, we will add in 3 more cases. Cases everywhere. So what's the next case we want to listen for? It's going to be a key of A. And if we press A, we'll say the key of A was pressed. Let's continue down the list. When we press the key of S, the key of S was pressed. And then finally, when we press a key of D was pressed. So let's save this, refresh, and now if I spam the right side of the keyboard, nothing's happening. But if I press W, we get that console logged. If I press A, we get another. If I press S, we get another. And if I press D, we get 4 console logs, all listening for the correct keys. So that's perfect. That's what we want. But we now need to start editing our player's actual position. So to do this, we don't want to just console log stuff. We can actually comment these out or get rid of them Now that we know they're working, I'm just going to personally delete them. I do not need those. And I want to select our particular front-end player. How do I grab our front-end player if all we have is this large front-end players object that consists of all of our players? Well, with Socket.io, it makes this very easy. We have this socket object up here being created on line 4 from the Socket.io library. And this is essentially providing the connection to our backend. And when we provide this connection, the socket constant comes with a particular ID identifying the connection from this client up towards the server. So using the socket ID, we can basically grab a front-end player from the front-end player's object, which is associated with our connection. And if that's the case, we are grabbing our particular front-end player. So let's grab our particular front-end player within the event listener of keydown. When I press key of W, I want to grab our front-end players, and I can grab our particular front-end player by referencing socket.id. So I'm going to grab our player, and now I want to start pushing them upwards. So we have X and Y properties associated with our front-end players. I'll grab the Y property, and if I want them to go upwards, I'll subtract from the current Y position a pixel value of about 5. Now, given we did everything right, we're going to save this, refresh, and we should start seeing our player move upwards as I press W. So I think we're this guy up here. If I press W, we are indeed moving correctly. So off to a good start. Let's add in the rest of this movement. So let's copy this line, and then within key A, we want to start moving to the left. And to move to the left, we want to reference our X property, not our Y, but we are going to be subtracting from that. So this looks good for key of A. Now I want to go down when we press a key of S. I'll reference our Y property, and we want to add on to that. That'll push us down. And then finally, we have a key of D. We want to go over to the right. So we'll take our X property and add on a value of 5. Now with this, if I refresh, we can move all around in different directions. So off to a really good start right here, but a few things we need to take into consideration. One, really quickly, is sometimes to create a connection, it takes a little bit of time. So if we refresh and our connection has not been established to the backend and we start pressing down WASD, we might be trying to reference a player that does not exist. And if we try to reference a property on a player that does not exist, we're going to get a front-end error within the console. So if we want to prevent against that, we can write a quick if statement before everything that says if our particular player has not connected yet. Basically meaning if this player does not exist, by adding the bang operator right here, we are just going to return. We don't want to call any of the following code. And using an if statement with a return is just a cleaner way of doing the inverse of this, which would be wrapping the switch case within an object like so, or within curly brackets at least. And the reason I'm doing things the other way is just to reduce indentation. I think this is a bit cleaner. Make sure you add the bang operator. So now we don't need to indent the switch case. That's why I'm doing things that way. But that is the first thing we need to do, is make sure we prevent against any bugs that might come in. So that's one bug. But we are currently editing our front-end player's position, right? And if I refresh and start moving, yes, we are moving on the client which we are connected to, but we're not moving on the client who's connected to us. We're only moving on one browser, and this is what I meant by the server is going to control our positions and movement. So whenever we make some sort of movement using our keys at WASD, we need to send an event to the backend server. And the backend server is going to emit our new player position to all connected clients, including this right browser over here. And another reason why we're doing this is to prevent against hackers. So if we were to control our position on the front end, like we're doing right now, someone could head into our client-side frontend.js file and edit these values right here. Let's say they edit the value of 5 to something like 30. They have now just given themselves superpowers compared to everyone else, and they can move at a 30 times speed. If I refresh, they are moving like this, while everyone else connected is moving like this. That's essentially how hacking works within multiplayer games. Is someone can edit the front-end code, it's submitted to the backend, and then the backend emits that new position to everyone else. Looks like they're going super speed. So we want to prevent against this. We are not going to be editing all of our players' code on the front end, at least in regards to their position. We're going to be editing this on the back end, and to edit this on the back end, we need to submit an event whenever we press one of these keys. So to submit an event, we can reference our socket object, and then call an emit method on top of that. And what event do we want to emit? Well, an event of keydown. I'm just going to be consistent right here. This is arbitrarily named, but I think it makes sense. If we're calling a keydown event on the front end, let's submit it to the back end, right? So we have our keydown event. And what happens next? Well, we need to specify what kind of data do we want to send up with this keydown event. Well, I'm going to send up the data of key W. Same thing we're using for a case right here, just to indicate what key I am currently pressing. So I'm going to send that upwards, and I want to make sure that I do this for all of our keys. So I'm going to copy socket.emit and paste it within each of our cases. So we have one for key of S, key of A, key of D, and then key of W, but we want to make sure we're sending up the correct data type. So key of W here will actually be key of A, key of W here will be key of S, and then our last one will be key of D. And we don't actually want to move our players via the front end, at least not just yet. So I'm actually going to comment out this code and send us back into the Stone Age with how our players are moving, but this is okay to start. So now we have this key down event being emitted to our backend. We need to process that event on the backend and edit our players' positions over there. So let's go into backend.js and start listening for that key down event. To listen for that event, we'll reference our socket and then use the on method, and it takes one argument to start. It's going to be the string of the event, which we called key down, and then the second argument will be an arrow function, which looks like this. So this arrow function provides an argument, and the argument is going to be the data in which we're passing through as a pair with our actual event name. So it's going to reference this over here. I guess we could call this a key code. So within our backend, socket.on, we'll say this function right here is passing in a key code data piece. I think that makes sense. So really, we want to listen for certain events that come through based on whether or not we're pressing W, A, S, or D. And if that is the case, we can pretty much reuse the switch case statement right here, but on the back end. So I'll grab the switch case, go over to our back end, paste it in, but we want to make sure we're not emitting an event, or at least not just yet, to the front end. So I'll delete every instance in which we're emitting event. And now that we are on our back end listening for these different events, we can start saying how we want to edit a particular backend player's position. So let's grab our particular backend player. And we can do that kind of the same way we are grabbing them on the front end. But on the back end, we're using a backend players object. So we'll grab backend players, and we can reference our one particular player by getting socket.id. And then we can start editing their Y value because we are pressing a key of W. So we'll take Y, and then subtract from it a pixel value of 5. We can delete this comment right here because that is referencing our front-end players. And now we have a way to edit our back-end player's position on the Y-axis. We want to do the same thing for every single key, just making sure that they are going in the correct direction. So one thing we could do here to make things a little quicker is we could uncomment these commented out lines of code, which edit our front-end player's positions, right? So we can grab backend players and replace every instance of front-end players with backend players. So now we're editing the backend player's position whenever we press W, A, S, or D. We want to make sure we're not going at a speed of 30. We're going at a speed of 5 whenever one of these is pressed. And yeah, that is how we're going to start editing the X and Y properties of a particular backend player. And one quick thing here is we're no longer using event.code. We're using key code, so we need to make sure that we're switching that out as well. And if we save, refresh, and try to move around with WASD, we're not going to see anything on the front end. And that is simply because, yes, we are editing the backend player's positions, but we are not editing that on the front end. We're essentially not sending it back to the front end is what I'm trying to say. So we want to make sure that we're doing that. For what? Well, not for every event, because if we just have all these players spamming up events to the back end, things are going to get pretty dicey if we try emitting all these events back to the front end. It's really going to start clogging up our server. I personally would not recommend that. A typical way to do this is to emit a ticker event. And basically a ticker event is an event that occurs at a specific period of time, such as 15 milliseconds. And this event that occurs emits data corresponding to our game with all our backend players' positions, emits all these positions back to the front end at this specific rate. That way, we're not clogging up everyone's front end with all these different requests that are coming in. We're only sending the exact data we need at the exact rate we want it at using this ticker functionality. So to add in this ticker functionality, we can use a set interval method within backend.js. And you want to make sure that this is placed outside of your io.on connection. Otherwise, you're going to create an interval for every user who tries connecting to your game. We do not want that. We only want one interval associated with our whole app. So we're placing this outside of connection. And set interval takes two arguments. The first is going to be an arrow function. And this is going to be the code that we call at a particular rate. The second argument is going to be the rate in which we want to call this arrow function at within milliseconds. So I want this called at a rate of 15 milliseconds. And that is going to give us a frame rate of, I believe it was, let's do the math, 1,000 divided by 15, a frame rate of 66.66. And no, I did not choose this because it is the devil's number. I chose this because this is what Valve, the people who make Half-Life, Portal, and so forth, recommend for a backend tick rate. They said call this at every 15 milliseconds. This gives us about 66.66 frames per second. It's going to make sure that our game is running very smoothly and that we're emitting all of our player positions at a good rate for everyone. So if this rate doesn't work for you, blame Valve and not me. So what do we want to emit every 15 milliseconds? Well, we want to emit update players. What this is going to do is not only control which players are added and removed from our game, but is also going to update all of our players' positions. So let's keep it here, but let's also add it to set interval and paste it in. So now every 15 milliseconds, we're going to emit update players to every client connected to our game. And what are we emitting? Well, all of our backend players, which are going to contain all their new positions and so forth. So what we need to do next is go back to frontend.js and see where are we listening for update players. It's going to be right here on line 18 for me. So yes, we're looping through our backend players and we are adding frontend players if they do not exist currently. But what about when they do exist? We need an else statement right here after the if to listen for that. So if a player already exists, we're going to call the code within this else statement. What code in particular do we want to call? Well, we want to reference the current front-end player we're looping over. We can get that by referencing front-end players and then also referencing the ID we're getting from our back-end player's object. So we're getting the front-end player associated with the back-end player, which we're looping over. We can grab their x and y position by adding on .x. And if we set this x position equal to this one particular backend player we're looping over and get their x position, we're going to be moving our player on the front end based off the position on the back end. We need to make sure that we do the same thing for y though. So I'll duplicate that line, replace x with y in both spots. And yeah, this should be all we need to start seeing our player move from the back end but onto the front end. So I'll refresh after saving that, and now if I press D, you're going to see that we're moving to the right. If I press W, we move up. If I press A, we move to the left, and if I press S, we are moving down. Now, why don't we see the same movement happening over here if the server is controlling our movement? Well, you need to make sure that you're refreshing on both of these, so both of these have the updated code. So you'll see I refreshed on both. If I start controlling from the left-hand side over here, now we have that player movement in place from the back end, which is the authoritative server controlling our player. If I select this over here, we start moving, but we're moving in both places. So really, going back to our checklist, we can now check off authoritative server movement. But we're not done just yet. We now need to move on to what is known as client-side prediction. And another jargony buzzword, I know, but If I were to explain this to you as simply as possible, all this means is we're going to immediately move our player. I essentially learned all of this from a blog on making multiplayer games. I believe the website was Gabriel Gambetta. Apologies for getting that wrong on the last name. I'm sure I did. But it basically goes over all this in more detail. Client-side prediction, server reconciliation, and player interpolation. When and why we use them. I'm going to give you a brief description of when and why we're going to use them within this video. So let's just get right on into it. What is client-side prediction and why are we even using this in the first place? Well, looking at our game, our movement is controlled by our backend. And although it's hard to see any delay between our inputs and our actual player movement right now, there will be some once we upload this to a server somewhere out there in the world, because that is where latency comes into play. A server by default will have latency associated with it, and latency is just lag, it's delay, because requests take physical time in order to travel from point A to point B. And point A is going to be our computer, point B is going to be the server. We need to make a full request going to the server and coming back to our laptop. That takes time to do. Even if it is light, moving at the speed of light, it's going to take some time. And sometimes that time can ruin our game because it takes so long to get the data back over here. And sometimes when we press down on our keyboard to move our player, there's going to be a delay associated with that movement if we keep things as is by just using authoritative server movement. So I can illustrate this a bit further by going into backend.js and increasing this time right here where we're actually emitting our backend player's position. I'm going to change it to a value of 500 milliseconds. So now our tick rate is 500, right? If I press D, you're going to see that there is a slight delay when I press D compared to when we actually move our player. It might be even a little more apparent if I change this to a value of 1500 and try changing our speed right here in all four locations to something a lot larger like 30. If I save this, refresh, and I press D over here, watch this. I hit D, hands up, but we took a little bit of time to move over. There's this huge delay right there. And this delay is representative of lag that might be associated with your server depending on how many people are connected, how well off your server is in regards to its infrastructure, and so forth. So it's very likely that you could get some really bad lag at some point in time, and we need to compensate for this. This game right now is unplayable just based on how we are moving our player. Because it is unresponsive, it's not snappy. When I press a D key, I immediately want to see our player moved over to the right, left, up, or down. And we are just not getting that with this current setup. And that is where client-side prediction comes into play. We're going to immediately move our player when we press down one of these keys on the front end, only our front end though, and then eventually the server will come back with our position of where the player should be, and it's going to be emitted to all our clients, so they are going to see our position, but we are going to get the effect as if we immediately moved there. This is more of a way to make your individual player snappy rather than focus on everyone else's. And we will fix the other player's movement, but this is for us personally. We want our game to be as snappy as possible. This is why we're using client-side prediction. So how do we immediately move our player when we press down a key? Well, if we go to frontend.js, we had some code which immediately moved our player. We just commented it out because we started to control our player's positions from the back end. But if we uncomment this out, we are going to get the immediate effect of our player moving to their exact position of where they should be, because our value right here, our speed value in which controls where our player moves, is the exact same as it is on the back end. So if I move over by about 30 pixels upwards when I press W, we're immediately going to go there. We're going to call an event, which goes to the back end, changes our position, and then we're going to emit this back to the front end whenever we call io.emit update players. And it should put us in the correct spot relative to where we moved on the front end. Now, yes, someone could change these values, hack our game, and make it look like as if they are moving faster, but if they were to edit these values, it would only edit for their particular character, because all the positions are actually controlled by our authoritative server on the back end. As long as we have these values right here controlling our player's speed, we don't need to worry about someone hacking on the front end. They're not actually going to be able to change where they're moving because it's only happening for their computer. So let's uncomment out everything that moves our player on the front end. Save, refresh with our crappy lag in place, and if I press D, you're going to notice we immediately move to the position we thought we would be at from our backend server. And I can move around all over the place, and it's really, really snappy, even with that terrible lag. But you'll notice that lag is still occurring over here with our connected client. And yes, this is how things are going to look to connected clients at the moment. Pretty freaking terrible, I know. But we will fix this, and that's going to be in one of the later steps within this episode. But for now, this is all client-side prediction is. It's just immediately moving your player when you press down on a key. Now, while we're at it, our movement isn't great, especially if we want to start moving in a diagonal fashion. Say I'm holding both W and D, I want to move up here. It's just not going to happen with our current way in which we are moving our character. So while we're at it, let's fix this up. Instead of editing our player's position on the front end, and also editing them on the back end, like we're doing right now, we're going to keep our switch case in place, but we're going to use a front end set interval to call this particular block of code every 15 milliseconds. I'm going to sync this up with what we have on the back end over here. Let's make sure we're changing 15,000 to 15. And now I want to start listening for which keys a user is currently pressing down. We can have multiple keys pressed down, W, A, S, or D, but we need a way to track all four of these keys and whether or not they're pressed down or they're lifted up on. So what we can do is we can create a const called keys, set it equal to an object, and this object will have keys inside of it, such as W. And the way I like doing this is assigning this to an object with a pressed property equal to false by default. And then we just need to take into account our other three keys. Easiest way to do that is to copy and paste the keys. So W, A, S, and D. So now that we have a way to track all four key presses, we kind of need to take the code that we have right here and place it within this set interval. So if a key is pressed and we run through this interval of 15 milliseconds, we're going to listen for if that key is pressed. And if it is, we're going to call one of these right here, such as moving our front end player up and then emitting a key down event with key W. So let's grab this statement right here. Go inside a set interval and say if what? Keys.w is pressed, what happens? We call this front end code that moves our player, and then we emit that front end, or we emit that back end statement with key W to actually move our player on the back end. But right now, we don't have a way to tell if W is being pressed down. To do that, we can go inside of our switch case and say if we actually did press down our key of W, we want to take our keys object, grab W, grab pressed, and set it equal to true. Great. But now, what about if we lift up on this key? Well, we can add in one additional event listener. So grab window, call add event listener, and listen for a key up event. So kind of the inverse of key down. Now whenever we pull up on a key, this arrow function is going to fire. We don't need to, well, I guess we do need to reference an event object. So let's grab that event. And we can pretty much add in the same switch case statement that we have right here. Let's just grab everything within our code block of key down, paste it within key up. And if we lift up on a particular key, such as key W, keys.w.pressed will be equal to false. We want to do this for all four of our keys. So we'll delete all the blocks which move our player. Grab key W pressed, switch it to key A pressed. Same thing for S, and same thing for D. So now we're setting all these to false when we key up on one of these particular keys. But we need to make sure that we're setting them back equal to true whenever we key down on one of them. And we also need to make sure that if one of these keys is pressed within set interval, that we're calling the associated movement code. So let's grab our key A movement code and say if keys.a is pressed, then we're going to move our player and submit an event to the backend. And notice I didn't use an else if right here. Why? Well, I want both of these to function at the same time. If W and A is pressed, then we're going to start moving towards the upper left-hand side of the screen. If I were to use an if else, then only one of these statements would be called at a time, and I don't really want that for the way my movement should work. I want to be able to move in diagonal directions, which is why I'm calling multiple ifs instead of just an if else. So now that we took that key A code, we can call keys.a is pressed, set it equal to true, and now we know when this is true, we will call the following movement code. Now finally, we need to do the same thing for S and D. So real quick, we'll add in an if that says if keys, key S is pressed, we want to call the following movement code. Doing this real fast right here. And then when key D is pressed, keys D pressed. What happens? We're going to call this following movement code. So finally, in order for these to activate, we just need to set their values of pressed equal to true. So when key of S is pressed, we're setting that equal to true. We're going to call the code up here. When key of D is pressed, we're going to call this code right here. Now this should make our game a lot more responsive compared to just managing everything within our event listener. Let's save, refresh, and try moving around. So immediately I have a bug, happens all the time as a coder, we're not perfect. Let's just click where this is coming from. And yeah, it looks like I'm referencing key.s instead of keys.s. So right about here. Looks like I deleted the s within keys. Let's save that, refresh, and start moving around. And yeah, wow, that is really, really responsive on both of these sides running at 15 milliseconds. So might be a little too fast. I think you can agree with me there. We just need to decrease this value on the front end and the back end. And it's kind of annoying to have to update this in 4 spots. So let's create a const called speed and set it equal to the value we want our players to move. I'll decrease this to 10 and then replace these 4 values with this constant. And I'm selecting these 4 by selecting 1, hitting Command D within Sublime Text, and then deleting it. And now I can reference speed really quickly by changing this in 4 spots at the speed of 1. So if we change the speed here, we want to do the same thing for the backend, otherwise our movement might get unsynced. So over here in backend.js, I'm creating that speed const, and then I am replacing these 4 values with the constant. So let's refresh, and yeah, I like that a lot better. It's very smooth, very snappy, and we can see that going on over here on the right hand side. Also very snappy because we're running this at 15 milliseconds as our tick rate. Now this whole client-side prediction thing and player movement, it is meant for your player. I can't iterate that enough. Let's try essentially making our game pretty laggy by switching this back to 15,000 or 1500, excuse me. And then on the front end, we will do the same thing. We'll set this equal to 15,000 for our tick rate. It's going to go very slow. If I were to save and refresh that, and I hit D, we immediately move over to the right, and eventually our server catches up with us. But that's kind of why we're implementing this client-side prediction, is to move our player, or at least give off the illusion as if we are moving in a very snappy-like movement, because we want our game to be as responsive and as fun to play as possible, regardless of any lag that might come into our game. I understand this is an issue over here. We will be fixing that. But with this code implementation of player movement with client-side prediction, we can check off that task right there. Next, we're going to focus on server reconciliation. Another fancy word, I know, but what this means essentially is fix any lag for your particular player. We're really going to hammer out our own player's movement before we do other players. Now, it's probably good to draw this out for you guys, because otherwise I think you'll have no idea what I'm talking about here. So let me go ahead and, I think I just exited out of that, oops. Let me go ahead and bring up my Blackboard here. And like I said, we're focusing on server reconciliation. Now, what is the issue that might occur? So let's draw it out. We have our main server right here in the middle, taking and processing client requests. This is a client over here. This is a client over here. They are both sending requests, and they are both receiving requests from the backend. Okay, that's simple enough. But an issue arises based on how fast these send requests to the backend server. So let's say player 1 right here is just a pure spammer on the keyboard. and they are sending a multitude of requests to the backend server. This timeline right here resembles how many requests are being sent up within a time span of 15 milliseconds. So like I said, huge spammer guy. They are just sending up 1, 2, 3, 4, 5, 6, 7, 8, 9 requests to the server. And the server is going to try to process all of these requests and eventually send them back. But sometimes some of these requests get processed on the front end before the back end can send back the updated player position. So let me try to illustrate this. This is going to represent player 1's player. Now they just sent up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 requests to move their player over to the right. So we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have client-side prediction in place. That immediately moves our player over here, at least within our own client's display. So we're immediately moved over here, but the server got these 10 requests, right? They got these 10 requests, and they are only sending back this one right here. This is request number 6. So the server, within 15 milliseconds, the tick rate of the server, only got to request number 6, and it sent back our player's position as if they were at position number 6 over here. So where's position number 6? 1, 2, 3, 4, 5, 6. It's saying that our player should be right here, even though client-side prediction moved our player over here. So if our player travels all the way to the right, and then the server says, actually, no, move back here, we're getting this jittery effect where we go over and immediately are placed back. We need to take into consideration that the server might be a little bit behind our actual front-end movement code. And if that is the case, we need to understand that there are 4 outstanding requests right here, 1, 2, 3, and then 4, which we need to add on to our back-end player's movement. So right now our backend said we're over here. If we add on these 4 additional requests, 1, I'm trying to get that. Let me get the player. 1, 2, 3, 4. We're going to be placed in the correct spot where client-side prediction placed us. So what we're doing right here is we're essentially getting the difference of the unprocessed commands from the server, which are going to be these 4 guys right here. These are the unprocessed commands that the server did not get to, and the server will send back an ID associated with the request it processed. That ID is going to relate to where it last left off. So if we send back a request with an ID of 6, we know that we have an ID of 7, an ID of 8, an ID of 9, and 10, in which we need to apply to our player's position over here. So every request is going to have an ID associated with it, and these IDs are going to be used to get the outstanding requests in which we need to move our player over to their correct position on the front end. I know this is confusing, but really you need this in place in order for your game to be as snappy as possible with latency and other considerations that are going to come into play as you start to upload your game to an actual server. So this is server reconciliation. We need to code this effect right here. So how do we begin? Well, we need IDs associated with each of our movements, and we need to start tracking our player movements in the first place, and then send those movements up to the back end, along with any other movement requests we might have. So how do we start tracking our inputs? Well, right above set interval, I can create a const called player inputs, and it'll be equal to an array. Now, whenever I press down a W key and I emit this to the back end, I can take our player inputs array and start pushing in the exact input in which we want to happen right here when we press a key of W. So I'm going to use an object, and I know that each input needs a sequence ID associated with it. A sequence ID is just going to be equal to the number associated with the event we are currently looping over. So let's say that this object's sequence number is going to be equal to a variable called sequence number. Now we need to create this in order to assign it. So let's create a let a sequence number equal to 0 to start for every client associated with our game. And whenever we press a W key and it gets registered within set interval, we're going to take our sequence number and add 1 onto it. We're going to do this for every key pressed down, but let's continue focusing on our W key. Now, if the variable name right here is the exact same as the property name, you don't need to reference the variable name. This is the exact same thing right here as this. So let's use the shorthand method to clean our code up a little bit. And then I need to indicate how we are moving our player within this input. So I want to reference a dx property. And dx is essentially short term for velocity, or I believe that's what it is. That's what I've always used. And I want to indicate how am I moving on the x-axis when I press down a key of W. Well, we're not, right? So dx is going to be equal to 0. But how are we moving on the y-axis with dy? Well, we are subtracting from our current position the value of speed, which means our event, whenever we press down W, we are subtracting from the y-axis a value of negative speed. We're just simply pushing that into our player inputs array. We want to do this for every single input though, so we'll grab those two lines of code and paste them with an A, S, and then D. But we're not done just yet, because whenever we press an A key, we're not moving upwards anymore. We're actually moving to the left, so we need to specify for dy that dy should be 0, but our dx should be negative speed. That'll move us to the left. And then what happens when S is pressed? This is when we're moving down. So yes, dx will be 0 in this case, but speed will be positive. And then we have our D key being pressed. What happens in that case? Well, dx is going to be equal to speed, and dy will be equal to 0. So we're pushing in this player's array essentially. And watch what happens as I console log this out. Player inputs array. Save and refresh, and I start pressing all these different keys. It just fills up massively, and this looks like overkill, and yes, it kind of is to start, but we're going to be splicing out of this. What are we going to splice out? Well, we're going to be splicing out the original few events in which we don't need. These events right here were already processed by the server. We don't need them anymore, but we need to focus on the last 4 remaining events to push our player over to the right to their correct position. So the array is never going to get very large at all. We're always going to be splicing out from it, and then we're going to loop over the final events, apply them to our player's position, and then delete those from the array's existence altogether. And that is going to keep our array nice and clean, but it's going to place our player in the correct spot no matter what, no matter if we have any weird server lag or anything like that. So now we have this sequence number associated with each event. We need to make sure that we're sending this up to the backend so that the backend knows which event it is currently processing. And once it has that event number, it can send it back to the front end, and then we can tell on the front end which player inputs we need to splice out before we apply them to our player. So if we need to send this to our backend, we're going to send up more than one argument. Well, really, I guess we're only sending up one argument, but we can make it within an object so that we can send up 2 properties. So I'm wrapping key W within an object, and that means I need to assign this a property, and I'll call that key code, like so. But I also want to send up our sequence number associated with this one event. And I want to make sure that I'm doing that for every instance in which we are emitting a key down event. So right here, I'll paste that in, right here, paste that in, and right here, paste that in as well. And since I'm just pasting this in from key of W, you want to make sure that you change your key string to the correct key. So when we press down A, I'm referencing key of A. When I press down S, that's key of S. And then when I press down D, that is going to be key of D. But we are indeed sending up the sequence number now. So let's go to backend.js where we're listening for key down. Now key code is going to reference the full object that contains a key code property and also our sequence number. Therefore, we can use some object destructuring to get the actual key code directly. If we were to wrap this within curly brackets like so, now we are going inside of this front-end object right here, this whole front-end object, and we are grabbing the property of key code directly, which is going to be key S, key A, key W, or key D. And we can do the same thing for sequence number to grab this directly by adding a comma next to our key code within this backend function and saying I want to grab the sequence number associated with this event. So now that we have the sequence number associated with each key down event coming to the backend, what happens next? Well, we're going to store the sequence number with each individual player being stored within backend players right here. So whenever we create a backend player, let's add a sequence number and set it equal to 0. So no player will have any sequence happening when they are first created. This is only going to increase as a player actually emits events to the backend. And we can specify which event number we're currently on for each individual player by grabbing the individual player. So we'll get backend players, reference the individual player sending the event with socket.id, and then we can change the sequence number property that we created up above to the sequence number coming through our front end. And that should track which sequence or which event we are currently on with each individual player. And now we can use that on the front end to apply server reconciliation, placing our player in the correct spot in case we get a massive lag spike or something along the lines of that. So now, when we emit update players back to the front end, we're going to have a sequence number associated with them so we know which event they are on. Let's head back over to frontend.js, go into update players, and when a player already exists, we want to move our player in a particular fashion. So right now we're just assigning their x and y equal to the backend player x and y. That's totally fine. What this does right here, going back to our Blackboard, is it's going to place our player at a position of about 6 when we were doing the example. So we press the key 10 times, we move over to the right, and the server is placing us right about here. This is where we're currently at within our code, right here with these 2 lines. But now we need to apply server reconciliation, which takes into account these 1, 2, 3, 4 extra events to push us back over to the right. So the next step of this process is going to be splicing out the events which were already processed. It's going to be these about 5, 6 events. And this whole blue line right here, you can think of this as our player inputs array. That's all this represents right here. So we want to splice out the events which were already processed. And to do that, we can grab player inputs and then call find index to find the exact index of the event we are currently on. So our player inputs are going to contain that object with the dx dy and the sequence number. So we'll say we're going to loop through every input within the player inputs array and then call the following. We want to return a certain condition which specifies which index are we currently at based on the backend sequence ID. So each backend player is going to have a sequence ID or a sequence number associated with them. Let's double check this. Yes, backend has a sequence number associated with it. So each backend player will have the sequence number, and we want to find the index of the event associated with the sequence number that was passed through the backend. So all we need to do is grab input.sequence number, and this should find the exact index of the last event that the server processed. So we can get that index and assign it to a constant called last backend input index. And then we can use this to splice out all the events which were leading up to that selected index. So right now we are selecting this one particular index right here. This is what we're getting. This is about index 6, 5, whatever it might be. And we're going to splice everything up until this index to freshen up our array. So let's grab our player inputs array and then call splice. And splice takes 2 arguments. The first is going to be at which input do you want to begin removing numbers? We want to start at 0 from the very beginning of our array. And then second input is going to be up to which index do you want to remove all these numbers or inputs from? We want to go all the way up until our last backend input index plus 1. So with this code, we're essentially removing all these inputs we don't need, and we're going to focus on the last few. So we really only want to call this if this index was actually found in the first place. And if 1 was not found, it's going to be a value of -1. So as long as last backend input index is greater than -1, then we can splice out all those non-needed inputs from our player inputs array. So now that we have these 4 remaining inputs, we need to apply them to our player's position. And to do that, we just need to loop over these 4. So we can grab our player inputs, call for each, looping over each of those, and say for each input still left within our player inputs array, we're going to take our current player's position, so front end player's ID X. we're going to take that player's position and we're going to add onto it the value associated with our inputs, dx. Remember, we were storing this down below right here when we created a new object to push into our player inputs array. We have a dx and a dy associated with each input. So for the remaining inputs, we want to add to not only our x, but also our y, the inputs dy. So these are the remaining events that are going to push our player over to their correct position, no matter if there was lag from the backend server. So let's save this, refresh, and start moving our player. And we have a definite issue here. It looks like we're moving all of our players based on our own player's player movement. And server reconciliation is really only for our player, not the other players. So what we need to do is state that all this code right here should really only be for our particular player. And we can do that by wrapping this within an if statement that says if the ID of the current player we're looping over is equal to our socket ID, meaning this is our player, then that is when we want to call all this server reconciliation code. But we do want to take into account that our other players need to move as well. We just basically got rid of showing other players' movement on our own screen because we don't have a way to receive those backend requests that are actually updating our players' positions. So these two lines right here, we want to add an else statement at the end of this if. It says for all other players, we want to take that backend player position and assign it to our front-end player's position. So now we're going to manage all other players' positions and then our own positions with client-side prediction and server reconciliation. So let's refresh. And yeah, that is only going to be moving us. We still have that ridiculous lag over here. Let's get rid of that. Go over to backend.js, change our tick rate to 15. Should get rid of the lag, refresh on both screens, and yeah, that is looking absolutely great. So now we need to make sure that we are using interpolation for all the other clients connected to our game, because although it looks great right now, once we start adding more and more lag to this, things will not look great for the other people connected to our game as we start moving around. Things are going to look very choppy, and I'll illustrate this shortly, but for now, we're going to go back to our to-do list, which I exited out of, and check off server reconciliation. So finally, we're going to focus on player interpolation now. Fancy words here, I know, but really this just means smoothing other players' movement. So it looks very smooth at the moment, right? But what happens when we get our best friend lag from the server? Well, let's illustrate this. On the back end, we're going back to our crappy tick rate of about 1500. And I want to increase our speed here so that you can really see how our players look as they move long distances with lag. So where is speed defined? It's going to be up here. Now our players are going to move 30 pixels. We're going back to that ridiculous rate. And on the front end as well, we want to change our speed to 30. So let's refresh on both screens, and I'm going to hit D a couple times. And it looks great on our screen. We implemented that server reconciliation and so forth. Looks absolutely amazing. But what about over here when someone else is listening to our movement? If I move over to the right, it takes a while to get there, and they just teleport over there. No matter where I move, there's just teleportation happening because that is when the backend is emitting the updated player position. And if the backend is emitting this at a low rate, such as every 1500 milliseconds, which who knows, with really bad lag, that could be the case, we're going to have teleporting players all over the place. So rather than just teleporting a player to a particular position, we are going to interpolate them to a position instead. And all that means is we're going to fill in the gaps as they move across the screen to these new positions outputted by the backend client. So how do we add in interpolation? Well, right here is where we are setting all of our other players' positions. And we're not just going to set them this way. We are going to interpolate to their new position instead using the green sock animation platform library. It's called GSAP, and it is already within our project over within index.html. You can see I imported GSAP right here. So we can immediately begin using this within frontend.js. So to begin using GSAP, we can call gsap.to. And this is just a simple interpolation library. So it's going to create a small animation that interpolates a particular value from point A to point B. What we're doing is we're taking our current X position and we're going to interpolate it to our new one. And it's all handled for us with gsap.to. So the first argument is going to be the object in which we want to interpolate. In this case, we want the current front-end player we're looping over. Once we have that object, we can add a comma and then use the second argument, which is going to be an object, to specify what properties do we want to interpolate. Well, we want to interpolate both X and Y. So I'll select X and say, what position do I want to interpolate to? Well, we have that available to us with backendPlayer.x. If we do the same thing for Y and say that our current Y position should be interpolated to backendPlayer.y, we're going to get this nice animation associated with all their players connected to our game. But it should be noted, we want to change the default duration associated with this animation, because otherwise we might get some jitteriness and choppiness associated with this movement, as we might not have made it all the way to point B before our backend code essentially updates all of our players' positions. So our duration should be at our exact tick rate associated with our front end and back end, and that is going to be 15 milliseconds, which should be 0.015 seconds, I believe it is. Correct me if I'm wrong. It might be 0.15, I want to say. Yes, it is 0.015. Sorry, it's late and my math is bad. So we have our duration associated with our tick rate, and there's going to be easing associated with your animation by default. Easing is just basically whether or not your animation accelerates or decelerates at particular points throughout the animation's duration. And I don't want any easing associated with this. I just want to move from point A to point B. Therefore, I'll set our ease equal to linear. If you need the values for this, what ease can be, just look up gsap, and you should be able to find that out. But this is all we need to get going, and we don't want to set our position immediately. We're going to interpolate to it, so we can delete these two lines right here. And let's see what this looks like. Give it a save. Refresh both screens, because we're now going to be looking for the other player's movement. And if I start moving around, yes, we definitely have some interpolation associated with our player over here, albeit it is not very good at all. But it will get a lot better. Right now we have an absolutely ridiculous lag rate, which is 1500. You're pretty much never going to see that. 100 and above is considered bad for gaming. So really it does make sense if we go ahead and decrease this to something more realistic like 100. And if I refresh on both screens, you can see that we definitely have some interpolation associated with where our player moves. And we're not going to be moving this fast either, so let's get something a little more realistic. Let's go back to a little faster than 10. Let's do 15 on both the front end and the back end. Find our speed constant. Replace that with 15. And you can definitely see that interpolation taking effect. We're no longer just completely teleporting from point A to point B. We're actually kind of moving there in animation sequence based on where our new backend position is going to be. So it still looks pretty crappy right now. Let's just go back to the defaults. Speed of 10 in both locations. And then I want our good tick rate, which is going to be 15. So change 15 there. Change 15 here. It's already there. Let's save, refresh. And now we have even smoother movement because we're interpolating, and we're also setting our position every 15 milliseconds. So I know it's kind of hard to see that interpolation taking effect because our interpolation rate is so fast, it's matching up with our tick rate on the back end. But that is definitely going to help smoothen out any lag that might occur that's associated with our player on the back end. So we might need some tuning up before we actually launch this, and we're definitely going to tune things up once we see how this functions on an actual server with lag, internet, and so forth. But this is a really great start for getting you going and starting to understand a little bit of everything that needs to go into creating a back-end multiplayer game. Because it's not as simple as you might think. We needed to do things such as authoritative server movement, client-side prediction, server reconciliation, and now player interpolation, just to get our player moving in a manner that is not hackable. So I hope you enjoyed, and let's check off player movement.